So coming to verification languages, so Specman Elite, Vera hardware verification languages offer enhanced productivity to verification engineer by reducing the problem and time spent in creating complex test benches. So they are telling that instead of implementing the test benches with the help of PLI or any HDL, it's better you go with some verification languages. So two verification languages that is widely accepted in the industries are Specman Elite and Vera. Okay, so what they are trying to say means it will take less time to create a verification environment with the help of Vera and Specman Elite. Okay, even you can implement very complex test benches with the help of these languages. Design teams using these verification languages report productivity improvement of a factor of 4 times. So if you they are comparing, okay, if you are implementing a verification environment with any HDL, then and if you are implementing the verification environment using any verification language, so your it will productivity is improved by 4 times if you are using verification language. So the test bench creators are compact and easy to understand, so you no need to write more code. Okay, so it is very less compact and very easy to understand. Specman Elite generate automatic test automatically by capturing the rule from the design specification. So they are telling Specman Elite, okay, it will capture some of the rule from the design specification and it will generate the test. So the automation includes generating functional test, checking verification result, coverage analysis. So automation means like we are telling that everything is automated, means generating the stimulus, checking the verification result, and getting the report from the coverage analysis tool is what the automation is. Full no need for any human intervention. This is a manual process, like automatic process. Specman Elite also provide ease of verification test bench reuse. Also, when you have implemented one complex test bench using verification language, you can reuse that thing for different architecture. Now the Vera hardware verification language create a target model environment, automatic stimulus generation, self-checking test with error indication, and coverage analysis capability. So whatever capability that is provided by Specman Elite, same capability Vera is having. Okay, Vera also provide feature for ease verification test bench reuse. So both are approximately same. Okay, so legacy test bench created in Verilog, VSDL and C++ can be used with test bench generated using Specman Elite or Vera, thus protecting protected investment already made. What they are trying to say is, already if you have implemented your test bench with Verilog or VSDL or any C++ language, you can integrate, okay, that thing with Specman Elite, and you can save the you can use the already investments which you have made on Verilog and VSDL. So these language interface with hardware software co-verification tool. So even if you are having hardware software co-verification tool, during that time you can go with Specman Elite as well as Vera. So test bench can also be created in Verilog, VSDL, PLI or C++ language. So Cadence Test Builder tool, which is a part of Cadence Verification Cockpit, a comprehensive library of OOPS technique, can be used to create the test bench in C++. Now what they are trying to say is Cadence is having an open library for C++. Okay, so there are some classes they have implemented. Okay, so during that time means the Cadence is also providing one tool, that is Test Builder tool. So with the help of that Test Builder tool, you can implement your test bench much more easily by using the already existing libraries in the with OOPS techniques. Now coming to verification IP reuse. Okay, now TTM pressures on the product design cycle are focusing associate designer and integrator to reuse the available design blocks. So what they are telling that time to market is an important concept in semiconductor industry. Okay, so instead of designing each and every part of a SoC, it's better you can reuse already existing blocks. Okay, to ensure that the design are reusable, the design teams use guidelines such as modularity with good coding style, clear comments in the code, good documentation and verification test benches. So what they are trying to say is, suppose you are saying that your design is reusable, so what all the things are available? You should follow some common guidelines in order to make your design modular, you have to clearly explain the meaning of each and every statements whatever you have written inside your code. Good documentation and verification test bench. You have to create one verification test bench in order to verify that reusable code. Okay, just as the HDL based design blocks are reusable, it is desirable to reuse the verification test bench IP to enhance the overall productivity. Like usually we are saying that our RTL is reusable, like we will only sell RTL, but nowadays time to market is in concept, so these verification IPs are also saleable. Okay, that will increase the overall productivity of the team. So verification team put a lot of efforts into developing test benches. So if the test benches developed for one design can be used for other similar design, a significant amount of verification time is saved by subsequent design. So what they are talking about, the design reuse. Okay, so for example, a test bench developed to verify a platform based SOC for multimedia audio application can be used for multimedia voice over packet application with minor modification to the platform of SOC. Now they are taking one example and they are explaining that how they are reusing the same test bench that they have used to verify the multimedia audio application, and after that they want to use the same test bench to verify voice over packet application with minor modification. So that is what they are talking about, the IP reuse, verification IP reuse. If the system is verified using transaction based verification, the transactor and the test suite developed for the platform can be reused for voice over packet application. So basically they are telling that reusability is only possible in transaction based verification. Okay, where your each and every transaction and test case can be reused for voice over packet application. It is important to create the standard stimulus format so that the pattern used for functional verification can be reused across the multiple projects. So they are telling that whenever you are whenever you are generating some stimulus pattern, it should be very generic so that you can reuse that thing. For example, sample global system for mobile communication. So they are talking about GSM and automatic transfer mode, that is ATM packets data can be created for use in multiple projects. Okay, so what they are telling that if you are having ATM IP like ATM packet, like data packet format is there. Okay, similarly GSM data packet format is there, so you can use such type of you can use those type of test in different verification environment. What they are telling to what they are trying to say is, for example, sample global system for the mobile communication and automatic transfer mode packet data can be created for the use in multiple projects. So whatever you have created for one project, you can use that data packet for other project also. So similarly, test bench developed for verifying advanced microcontroller bus architecture or peripheral component interconnect bus protocols or functionality can be reused any system based on these bus. We know that PCI and AHB is two bus architectures. So if we have created some verification environment for these buses, means any core which is integrated with any one of these bus can be reuse this AMBA or PCI test cases. So modular and reusable test bench can be developed with test builder Vera on SpecManaLite. So they have given test builder, which is a C++ OOPS library. Vera, you can use Vera or SpecManaLite as a verification language, and you can implement reusable test benches. Now coming to verification approaches. Okay, so basically they have told one verification approach is top-down design and verification approach. Okay, second is bottom-up verification approach. Third is platform-based verification, and fourth is system interface driven verification. So they categorized the verification approaches in 4 categories. So first we'll see the top down design and verification approach. So in figure 1.9, okay,